All right, so this is your review guide. I'm not giving you any homework on this. If you can do your review guide, you can do your test. So this front page is going to be just like your notes for the first section. Growth and decay. You're either adding 100 or adding to 100, or you're subtracting from 100. So if you have an 8% growth, you want to keep your 100% so that your multiplier is going to be 108. But that's not what you'd actually multiply by. You would multiply by, to the left, 1.08. You're growing by 0.03%. You still add it to 100. Don't think about it, just do it. And then to the left, your multiplier is 1.003. Decay. You're decaying 7%, so that means 93% remains, 0.93. And then if you're decaying 0.5, you're left with 99.5. To the left, 0.995. These are your multipliers. I've seen some kids write percent. You're not doing a percent anymore. The next one says write a model. So like an equation for the following situation, and predict the population for the time period. 125 bacteria that double to 100% every hour. Then they want to know how many double every 8 hours. Okay, then you just put in your calculator. 75 bacteria that triple 300% every 30 minutes. Since we're going by hours, how many times does 30 minutes happen in an hour? Twice. You get 2 30 minutes in an hour. So it would be 30 minutes, and 4 hours would be 8 times. So just put in your calculator, 7 times 3 to the 8th. The next one, it says suppose you invested in $1,000 in a company's stock at the end of 2005, and the value of the stock increased at a rate of 15% a year. Predict the value of the stock to the nearest tenth at 2010 and 2015. So you start with your population or your money or your principal or whatever it is, and that's 1,000. You then multiply and then time. Well, you went from 2005 to 2010, so that's 5 years. And then you went from 2005 to 2015, that's 10 years. You're growing 15% a year. So your multiplier is 1.15, or you take 100%, add it to 15, get 115. To the left. It's the same thing here. Put these in your calculator. What would you get? What would you get sitting 5 years longer? What difference does it make? Now, it's not going to be extreme because you're starting with $1,000. Okay, if the initial amount of money was bigger, it would be way bigger. So when kids talk about, it's sad that we're not in class for this because we really start to talk about it. You want to save and have a nice chunk of money to start with and play around with these numbers. What happens if this was 10,000? What happens if this was 40,000? You'll look in your review packet or your class notes, and you'll see, I have a chart here. From a book. I think the growth or the multiplier, I want to say, was it 10% or 12%? I think it was maybe 12%. So that's pretty high for investing your return. But they showed a kid, Ben, if he just put $2,000 into the same account every year until he's 26 and never touched it again with a 12% return, he would end up being twice a millionaire when he's 65. If he just did that. So how much is that? 1, 2, 3, 4, 5, 6, 7, 8, $16,000, which shows Arthur 19 to 26 he did nothing, but then he puts in $2,000 every year until he's 65 and he's a millionaire. So Arthur never caught up, okay? Because exponential growth has a lot to do with time, and you guys have time on your side. So it's really important that in these years, start saving some money so that way you can invest. It's unfortunate we can't talk too much about it, but just play with some numbers. All right, so as much as there's exponential growth, there's exponential decay. Jessica bought a car for $9,500. the car declines at 12% a year. So whatever you paid for the car, it's depreciating, and you'll be left with 88% of the car. Now, you're gonna put that in your calculator, and your car is gonna be way less of value. That's why cars aren't really a great investment. We also watch a video, if you really are interested, about leasing cars. His name's Dave Ramsey. He has great YouTube videos to watch. If you're like, I'm not really good with finances, that's something I'm interested in, just watch YouTube videos. He has a great channel, but he has one, Car Leasing Explained. Dave Ramsey, I'd look into that. And they talk about cars and how much they depreciate each year. I believe on average, it's not consistent, it's not 12% a year, but the first year they said on average, I think was 19% you lose in your first year, and then it kind of levels off, but that's kind of crazy. Number 6, Jamie invested $1,500 into a savings account with a rate of 4%. So this is compound interest, and we might have not gotten to this in the notes yet. I'm going to save it towards the end. But sometimes we don't just have interest that hits once a year. We have compound interest. So you have your multiplier, then you're going to have your rate. Well, this isn't going to be your multiplier, but it's your rate. It's compounded quarterly. So taking that 4% and they're cutting it up into quarters, but this is the 1 to keep your 100%. So it's hitting that account 4 times a year for 5 years. So 4 times a year for 5 years is 20 years. And then you just put that in your calculator. Make sure, try to simplify it as much as you can, because some people just make calculator errors. And you'll get a little bit of more money than you would just hitting your account once a year with compound interest. So credit cards, for instance, that percentage just doesn't hit your credit card once a year, okay? That's monthly, but we're not going to get super into it. Just try to focus what's on your review, and next year you will see logs and exponential functions again. Okay, so how do we graph them? We know the shape is like this. -1 means that whole graph's going to go down 1. So I'm going to fill in here and graph it here. So I can put in any number I want. What numbers come out? If I put in -2, that's 1/4 minus 1. If I put in -1, it's -1/2. If I put in 0, it's -1. If you're like, whoa, you're going too fast, you can just do it in a calculator, do it off to the side. 8 minus 1 is 7. Okay. So then we graph. All right. So we put all these numbers in. Normally, your range is you don't go below 0. Remember when we graph these in our notes, you don't go below the 0 line. But this -1 is going to shift this whole graph down to 1. So you're not going to go below -1. So at -1, there'll be this imaginary line. It's called an asymptote. So let's graph it. I'm just looking at this. This doesn't seem right. Okay, so we put in -2. 1/4 minus 1 is 3/4. I put in -1, -1/2, I put in 0. Something doesn't seem right. 0, -1. Oh, it's because it's 1. Because when you put in 0, it's 1 minus 1, and you get 0. Sorry about that. Something was not clicking. Okay. 1 and 1. 2, 3. So yeah, did it work out? Every number could go in, and every number could come out until you got to -1. Therefore, there's an asymptote there. Here, if I put in -2, it's going to flip it because it's negative, and it's 2 squared, which is 4. -1's going to be 2, 0 is going to be 1, 1's going to be a half, 2 is going to be 1/4, 1/8. Okay. -2 is a 4. -1 is a 2. 0 is a 1. 1 is a 1/2. 2 is a 4th. 3 is an 1/8. So yeah, it just goes the other way because it's decay. Because if you have 1/2, that means you're only keeping half of what you have. The domain is still all real numbers. The range, though, is what it normally is. You can't go below 0. And there's an asymptote there. Okay, this last one, you might want to just skip over this and come back to it later when we talk about logs. But when you come back after logs, remember the domain and range flip. So your range is going to be all real numbers. But since ranges might be different, we have to figure that out. All right, so here, put in -2. Log 2, -2. 2 to what power gives you -2? Nothing. Log 2, -1. 2 to what power gives you -1? Nothing. Log 2, 0. No. Log 2, 1. Yeah, 2 to what power gives you 1? 0. 2 to what power gives you 2? 1. 2 to what power gives you 4? 2. 2 to what power gives you 8? 3. So you can just graph that. At 1, you get 0. At 2, you get 1. At 4, you get 2. At 8, you get 3. So it goes like this. But if you keep going lower, between 0 and 1, if you go 0.5, okay, you'll keep getting closer and closer. So 2 to what power gives you 1/2, a -1. And you'll just keep getting closer and closer and closer. That asymptote changes. So instead of x equals 0 or y equals 0, it's x equals 0. Domain is greater than 0. I know it's a little confusing, but if you're watching this, if you haven't done the log notes yet, then just fast forward and come back. All right. Which function has the fastest growth? Well, that's decay, growth, growth, decay, decay. 500% versus 300%. It's this one. And then it says, which one has the slowest decay? Decay, decay, decay. We know a third is 0.33. So if you're 0.33, that means you're decaying at a rate of about 66%. And 0.5, or 1/2, is the same thing as what percent? 20. So if you're decaying by 20, or I'm sorry, if you have 20%, you're decaying by 80. 1/7's even smaller, so the decay rate's even bigger. So the slowest decay is this function. Does that make sense? As the number gets bigger, it's actually decaying faster and bigger in the denominator. It says, what's the y-intercept for the last 3 functions? To find a y-intercept, you substitute in 0. If I substitute in 0, I get 1. 1 times 2 is 2. If I substitute 0 in here, I get 1. 1 times 6 is 6. If I substitute 0 in here, I get 1. Okay. Okay, it says write an equation in a logarithmic form. So you'd say log subscript 1/12 to what power gives me 1/144? 2. U to what power gives me 15/16? B. Next one, solve each equation for x. 2 to the x equals 128. So 2 to what power gives you 128? Is it 2? That would be 4. Is it 3? You kind of have to guess and check. Is it 5? That's 32. Is it 6? Okay, you keep going till you get the one you need. Here, x to the third equals 216. I'll put up answers for all these later. Take the cube root of both sides. What do you get? Here, 10 to what power gives you 4720? Well, if exponential form doesn't work, put it in log form. Well, there's a log button on your calculator. When you press the log button, it assumes you use 10. So just type log 4720, enter, and you will get an answer, an approximation. Here, if log form doesn't work for you, put an exponential. 8 to the x equals 1. 8 to what power gives you 1? 0. Here, we're condensing. We said addition can actually be multiplication. If the logs are condensed and you make one single log, you just multiply them all together. Here, same thing. So this 2 actually can go up to here. So it's going to be 24 times 3 squared. Subtraction's actually division, 2. Log b. Well, 24 divided by 2 is 12. So it's 12 times 9. 18, carry the 1, 9, 10, 1, wait. Okay. Here, 3 can actually go here. 2 can actually go here. So it's log, since it's all being added, it can be 1 log of 7 where there's multiplication. So it's x cubed, 3 squared, which is 9, y squared, which is y squared, times w. And you can rearrange it if you want. You don't have to. Here, let's deal with the inside first. That 2 goes here, so it's going to be log a n divided by m squared. And then this 3's here, so it would be log a, we're going to move the 3 up here, n cubed, m to the 6th. Pause it, rewind it, write it down, put a star by it. You guys need to ask questions. Nobody's been asking questions for the past 2 tests. But then I'm getting emails saying I don't get it after the test. You guys really need to start marking stuff down. Only a few of you. And then you need to start marking stuff down. That way I can do a video on your questions about this. So it makes sense when you have test time. All right. This one, you can move that 7 to the front. So 8 to what power gives you 64? 2. 7 times 2 is 14. Five log 5. We said before those are going to undo each other, so you just get 17. And this one, addition, is multiplication. When you condense to get 1 log, 10 times 50 is 500. This is division, divided by 4. 4 goes into 5 once. Sorry, I'm listening to my son. And I can't think, and I don't have my calculator. Let's see, 4 times 1, 2, 2, 0, 125. 5 goes into 125, so this becomes a 3. Okay. All right, last page. If you have 2 logs equaling, logs are exponents. What is a log? A log is saying, what is the exponent? So if they're telling you 8 to some exponent equals this, and 8 to some exponent equals this, and it's all equal, then these must be equal. And then you go ahead and solve. You bring 8x to the other side. Here, same thing. Addition is multiplication. This is division. Three goes into 4 once. 4 minus 4x. All right, so you had to do some work to get to that point. Now, 10x is going to be equal to 14 minus 4x because those logs are equal. And logs are saying what's the exponent and they have the same base. If they didn't have the same base, you couldn't do this. Okay. All right. Make sure when you're solving with logs, x equals 1. I mean, I'm sure they're fine for most of them, but plug them back in and see if they actually work. Because sometimes when we get negative numbers, that's okay. But if you put the negative number back in, it might not work because we'll never get to a negative value. So if we go back to our graphs, here, we don't ever get to negatives. So just make sure the negative might work, it might not, depending on how it fits with the other numbers. All right, log 492. Graphing calculators were invented in the 80s. And when I was in high school and up to a few years ago, graphing calculators only used logs with bases of 10. This has a base of 4. But as you saw in the one video, you can change the base. I could do log 92 divided by log 4. What's the base now? It's not appearing. What's this base? It's actually 10. It's called a common log. So it's so common you don't write it. Just like you don't write 1 when you write 1x. You just write x. So then put this in the calculator. You'll get your answer. And same thing here. Just type log 21 divided by log 5. And then 1 minus that, and you'll get your answer. And here, this is how you do it. So if this doesn't work, 7 to some number equals 208. There's not a pretty number, but we can put it in log form. Log 7, 208. So log 208 divided by log 7. Enter. And then this one, we subtract 1. Enter. Well, not enter yet. You have to do log 359 over log 5. Okay. And I'm not going to do this. If somebody wants to do this and they do it completely correct, I will give them the extra points that you see in participation in our class. All right, guys, please, please, please star things that you don't get, and I will go in length. I'm going to try and do a Zoom meeting Friday, and we'll talk then. I hope you guys are enjoying the beautiful day.